We can have a recap here. These are the files, libraries to be imported, and this is our API call request. Then comes the data ingestion part. This is our daily weather data. Okay, I think I have hard coded the end date. We'll take today's date. Okay, we'll call it again. We ingest the data again. Okay. Our info is good. So that, okay, so as that our minimum and maximum date. So we are not doing this weather code because standard scalar needs numerical numbers and the code needs to be retained in number form so that we can encode it later, and whenever needed we can map it and we can get the string. So far I have kept the code as it is and didn't retrieve any string method for that. Next is the feature engineering. Cyclical encoding, lag features and date features, everything, rolling average temperature and the temperature maximum, which is the target variable for us. So this will be our feature df. Minimum and maximum date are set. We will lose the last date. Okay, we will lose the last date because we will not have the maximum temperature for the next day. So for 15th our last date was 16, but after feature engineering it will be 15. We will lose the last temp max result so that it becomes NAN and it will be dropped at the end of the feature engineering. Also the top 14 rows here, see, date will be 15 but our minimum date was 1. We also lose those 15 because the lag features of 14 days will be NAN of the first 14 rows, so we will lose that also. This is not an issue, so we are going to proceed with the same. Then comes the train test split and time series split. Okay, everything is as per our plan, and this is our visualization. We had one more additional day, so I think we need to rerun it and we need to save the data again. Okay, so our featured data will be of 19 columns with 4170 entries. Okay, now we'll describe it. Okay, we have the standard deviation. So standard scalar will expect date, we'll expect only numerical columns, but date is a timestamp area, right? So we cannot scale it, so we have to drop it. We have this date under our day, month, week, day, and also day sign and day cause. So it is okay to lose the date. Whenever needed we can get it from the raw data. Okay, so no issues from that. Now a simple flow where how to declare an object for the scalar and how to perform scaling, but we are not going to fix this pre-processing step. Why? Because every model requires a different kind of pre-processing, so we are not imposing one pre-processing strategy to all the models. So this is just for an understanding. So we have chosen standard scalar, and now we will be dropping the column. So this is how we need to do the standard scalar procedure, because date will be in date time, so it is in string format, so it will not accept and it will throw us an error. Next, we are saving our xtrain and xtest, ytrain and ytest to our data paths. Also this is another trial. We'll see what to do. Before that I'll comment it. So we are also saving the raw weather df, that is the raw data, right? Before feature engineering and everything. So I'll be saving this raw data as a CSV. Okay, and this is how we will save the models also. An example to save the standard scalar is I will be using the .pkl extension, and using joblib.dump I'll save the scalar function, scalar object under this name, so in this path. Okay, so this is how it is done. Okay, Now also we saw how to see the correlations between our feature variables, and this was the correlation matrix so far. The intensity says the intensity of the color intensity says the intensity of the relationship between the variables. Okay. Our target is, see, are models of interest. One is linear regression, second is ridge regression, then comes the lasso, then random forest, then XGBoost. These are the all kind of regression methods, regression algorithms that we will be employing in our weather forecasting project, and we will see how these model behave to our data and how much it helps us in the prediction of our temperature. So my idea in the helpers file is, that is the methods that can be reused in all other models, is a common flow. One is load data, save model, and we have to load the model. We will be saving the model. Instead of calling every time, we will save the model once and we will call the model again. So we will be serialize and deserialize it once again. Then the scalar, that is the scalar, we have dumped the scalar, right? So in case if we need scalar in any way, we can call the scalar.pkl file using joblib and we can reuse it. And model evaluation, model evaluation is the same for everything. So we need to define the metrics and we need to call the metrics according to the model. Then comes the visualize model. Visualize model is something that it is not fixed to every algorithm, but my idea is, what if we can have take scatter plot. It will be easier to work for linear regression and everything. So I can keep a simple visualization that will be acceptable for all the models here, and if we need any other kind of visualization, we can employ that visualization in the model's notebook itself. Otherwise we can define it if with condition, like if we have this model, you have to employ this kind of visualization, so that we can reuse the visualization n number of times. Instead of defining it in the notebook, we can have it in the helpers file. Finally, inference. This is the most important part because we are about to focus the next 3 days. So we will define a function, okay, where we will load the data and load the model, load the scalar, and do the evaluation, do the visualization if needed. Otherwise, focus doesn't need that, but if we need to call this focus doesn't need model evaluation or visualization, just the inference, right? So I can load the model, say, and load the data and load the scalar and do the feature engineering steps and recursive forecasting. Recursive forecasting is one of the most interesting things that I have done in this project, and it took me time to understand why this recursive thing to be done and what is the effect it will produce in our forecasting because of recursive forecasting. Finally, for the next 3 days, the prediction will be resulted that we can see along with the values in our output. So this is the flow I wanted to be in the helpers file. Okay, so for that, first is our linear regression. Let's see what linear regression is first, then we can go into the model implementation. First, linear regression. Let's talk about regression. Regression is a statistical method used to model the relationship between our target variable and one or more independent variables. This is for continuous numbers, right? Our target variable will be y and independent variables will be x. X will be one or more, but our target will be only one. This is a continuous number. So what is linear regression? Linear regression tries to best fit a straight line. Okay, so that will tell the relationship between the model features and the target variable. So this is to predict the continuous numerical outcomes. Regression is completely for numerical outcomes, right? So linear regression is a supervised algorithm that learns to model a dependent variable y as a function of some independent variable x. That is, y is equal to a function of x. If we have more than one, if we have more than one feature variable, our model equation will be y is equal to beta naught plus beta 1 x1 beta 2 x2 till how many, like n is equal to the number of features plus epsilon. So Beta naught is our intercept, and these are the coefficients which are the weights for every feature that tells the importance of each feature, and this epsilon will be the error, that term to represent the unexplained variance. Okay, so see, if I have the straight line fixed to our model data points, there will be a difference between the actual value and the predicted value because of the straight line. That is a regression line, right? So this error is explained. So this is the residual, and this term is this term will represent the unexplained variance because of the difference that is between the actual and the predicted value. Okay, our major equation of line will be y is equal to mx plus c. So how linear regression works? So it works on the assumption that the x and the y variables have a linear relationship. How it is done? This is done by finding a line that best fits the data. That this is the fit line, this is the regression line. So what does fit mean? Here best fits the data, but then what does the fit mean? Fitting a linear regression model is all about finding the set of coefficients, that is beta 1 x1, beta 2 x2. These are the coefficients and its weights that best models y as a function of x. That is what defined in this term here. Y is equal to function of x. If we have a good set of coefficients, then our prediction will be good. Okay, how to find the coefficients? There is a standard way to do so is linear squares method. But what linear squares method will do is they will find where the minimum will be. That is everywhere the minimum is the loss, right? Where the loss is less, our model will be a better model. So this least squares method will go and find straight away the zero, where the error is completely zero, then our model will be best. So in that way least square methods work, but we have to learn the model's parameters, right? So for that we'll use the gradient descent algorithm. So by gradients the model will learn these coefficients instead of fitting it to the very minimum loss, that is 0, using the least squares method. For small data sets, both least squares method and gradient descent algorithm will find out the same point where the loss is minimum. Okay, so our ultimate goal is to find the least sum of squared residuals. So this is a Python code. We can use linear regression from sklearn.linear model, and we can use a model, fit it using xtrain and ytrain, and predict it with the x-test, and we can see the slope and intercept with model at coef underscore of 0, model at intercept underscore. These are the evaluation metrics. One is the mean squared error and the other one is the r-score. We'll see how our model implementation performs and what kind of values we will be getting for the error evaluation metrics. Okay. One difference are the gradient descent algorithm. I would like to suggest you to watch Josh Tamer's StatQuest, where you will be getting a very good understanding of the models, methods, functions, formulas, and the iterative solution of gradient descent algorithm. He's having some kind of like he is performing in a way where people can understand it very clearly, and his explanation is top notch. So try to visit his page, and if you have any doubt, you can directly go to the page and you can search for even gradient descent algorithm. He has every video. It's a short video, but you will have the maximum information that you can get out of that. So here gradient descent algorithm, this is an iterative solution. Why it is iterative means it will take baby steps to reach the local minimum. Okay, so when we fit a linear line with linear regression, we optimize the intercept and slope because of our we have the line equation, right? We have the intercept and slope. So in that way, when we fit a line with linear regression, we are optimizing that intercept and slope only. So this gradient descent algorithm is an iterative optimization algorithm that estimates the coefficients to yield a minimum of a convex function, that is the low prediction error. When we have low MSE, our model will be better, right? It will start from a random initial guess for the model parameters and adjust them to reduce the difference between the predicted and the actual values, that is the residual value. Okay, so least square method this sets the derivative exactly at 0, but our gradient descent what it does is, if the slope is negative it steps forward, if it is positive it steps backward. This is forward and this is backwards, so this will be repeated until it gets closer to 0, so and stops when the slope is so close to 0 that it cannot find a better value. So for standard linear regression they both find the exact same best value, but gradient descent is a very good optimization algorithm, okay, for this. Okay, first our basic idea will be, we'll create a trained pipeline, okay, then we will load the historical data, then available date will be of 15 June, right? So we will create an input and we will predict the next day value and we will save the next day value, and we'll update the lag features, date features, then add the new row, predicted row, to the data set, so that one prediction will be added to the data. With that we will do the prediction again, and we will do the prediction again for the third day. So this is the recursive forecasting. So with this repeated loop we will get the 3 days forecasting. This is my whole idea of the weather forecasting system. This will be an overview of the extended idea of my weather forecasting system. So employing weather DB and storing my data there, that is a raw data. And for model training, I'll use a feature engineering, then calculate all the features, then train test split. So keeping that train test split to our like feeding that train data to our model, then we will save the model. And for forecasting I'll get the recent history, so 1 to 15 to predict the next day. And because of this, with a trained model and history, we will forecast the next 3 days. Inside, during the forecasting, we will get the data and we will feature engineer it without creating the target variable, then adding the latest row to the feature history, then predicting it, and having next day as our, if I am doing the prediction for 15th June, this will have 16th June, the next day will be 16th June. Then the store prediction in our prediction list, we will create a list, then we have to create a new raw row and update our features, then append it to our raw history, then finally keeping the max lag plus 1 row, so that our history is up to, if we are calculating for 17, then our history should be till 16. 16 is our new prediction, so that we have to add that 16 also to our raw data, right? So we have to repeat it for the next day till our end days ends. Okay, here our end days will be 3, so that this will be executed 3 times. Then finally the forecast data frame will be resulted, which I have for, if our last date is 15, then our 16, 17, 18 predictions will be the output. Okay, this is our whole idea, and I have implemented as a trial. Then now we are going to implement it for real, and we'll see how this works out. Okay, so we are going to have the SQL and our forecasting and all these history creation, everything in our helpers file, and we will just will load the object and see what linear regression does in a separate notebook for linear regression. That file will have our model initiation, then taking our visualization, model evaluation, then finally calling the forecast and seeing the result in that notebook. So it is kind of an abstraction where we don't see what actually happens inside it, because we are just calling the method from another file. So this is how this is going to be. Let's see how well this works out. Okay, we already have our helpers. In our helpers file we have all the directories. Okay, so since we are going to use the SQL, I am also going to create a DB path, that is from, I'll use the data directory itself. that I can have a weather.db. Okay, so next import SQLite 3. Okay, then we need to first initialize our database. So it will be I need to establish a connection to SQLite. So my connection will be SQLite 3 dot connect our connection to this DB path. Okay, we have to connect it to the DB path. Then I need to update the raw data, right? So for that I need to have a raw data. Okay, in our file, where do we have that raw data? We have saved it somewhere. Yeah, so this is our raw data. We have saved it in a utils.data directory, right? So what I'm going to do is I'll create a def load raw data function. Okay, so from this I'll get the raw df. I'll read the csv from os.path.join of data directory. The name is raw data.csv. Okay, so we have a date column, right? So one simple idea is we will parse the dates before while reading, then we will return the raw df. Okay, and now I can get the raw data from here. So here I'll give load raw data. I'll call this method so that now we will get the raw data. Okay, okay, so not just getting raw data will establish a connection to give the data to the connection, right? So we need to create a query, okay, so that it will add the data. Okay, we need to change it to SQL path using the connection and the weather, like we have to give a name so that we can make the raw df move to the weather db. Okay, this is our weather db. Our goal is to move this raw data to this weather db with this connection established. Okay, so raw data dot to SQL through this connection. If already this connection exists, I will replace it. That's it. So no place of error here. I'll also drop the index and we have to give a name to this. So this will be our weather data. So now the connection has been established and we have moved raw data to the weather db. So we have to close the connection. This is important. Okay, so we'll also have a printed information that thus as a what we can do is we'll try to do this. Okay, we'll try to do this so that we will print success, connection established, and raw data moved to SQL DB. Okay, so if I get any kind of exception, I'll catch it here as E and I'll print the error. Okay, this as error and failed to load data to DB. இங்கே என்ன பண்ணலாம்னா we'll have error. Okay, so I'll close the connection. So fail to load data, whatever exception we are catching in E, it will be printed here. Okay, this is initialization. Then once initialization is done, we have created the DB, right? So our initialization is done. We have created the weather DB and we have updated the data. Okay, next we'll have these two models here. So one thing is over. Let's go and see whether we have our weather DB. Oh, we didn't run it, sorry. We have the raw data CSV, but we didn't run it, so we don't get the weather DB. Okay, once we'll try to run. Okay, so first where we can run is here. Okay, so this is the part. Once we got the raw data, we are going to initialize the DB. Okay, so I'm going to do it in a new line. Okay, initializing it. No initialize DB. Okay, I need to restart the kernel first. We have changed the helpers file, right? So I will restart the kernel. Okay, I need to ensure that whether we have all the data up to date, so I'll do it again. Now we will initialize the DB, utils.initialize DB, fail to load DB because missing column provided to parse dates date. Okay. One thing is we have dropped our date column. Okay, so that is why we are getting this error. But what I have done, okay, I misspelled the column. Okay, that is the issue. Okay, I have rerun the kernel now. Now connection established and raw data moved to SQL DB. We'll go and check whether we have the weather DB there. It will be inside data. Yes, we have got 10 seconds ago we have got the weather DB success. Okay, next we'll move on to our linear regression model. Okay, so what we will do is first we will import the utils, import os comma sys. Okay, from path lib. This is only way of importing. So parent directory, which is equal to, I'll give okay, I'll get the current working directory first and also the parent to the current working directory, and I will make it as a string so that it acts as a directory. Okay, instead of now if my parent directory, we are checking again, if my parent directory is not in sys.path, I will add this path append. Okay, that is the parent directory path to the system path. Okay, now import utils from that helpers file as utils, so that I can use utils dot any kind of method defined inside the helpers file. Next, for saving the model, we need import joblib. Then for everything, pandas and numpy. No need of any kind of visualization method like matplotlib or cbon because everything we will be doing in the helpers file. So now I'll just have pandas and numpy here. Okay. Once done, we need data, right? See. For first, we need load data function. That is to load the data for the model. That will be common for all the methods, for all the models. So I'll be creating it in helpers function, helpers file. So first is load data. Okay. We have four things: xtrain, ytrain, xtest and ytest. These are already available in our data that we have saved now. Okay, I'll take that. From the data directory, I will take extrain.csv here. Okay, and now the same goes for the other three: ytrain, xtest and ytest. Okay, we will load the data now. So we need to restart the kernel anyhow. Okay, utils dot load data, right? So we have all four in order. So this will be the order of output. So here, okay. Then we'll just check the shape of our train and test. We have our load data here and it will return these four outputs at the end of the function. So it will be utils dot load data. Okay. Also we can see the shape, that is print xtrain. We need the shape. Xtrain and xtest is enough to get the shape. Next, our model. We need our model, right? This is linear regression method. So, sorry, notebook. So from sklearn dot linear model import linear regression. Okay. So this will be a model. Then we have to create an object for us. We have the data now. Next, save model. So save model is nothing but we have to create the model now, then we have to save it. Okay, I'll create linear rate equal to linear regression. Okay, now I have a simple idea. So two things we have to do. One is our standardization for numerical columns and one hot encoding for categorical columns, because our data has both, right? Categorical column is our weather data. Even though it is numerical in number, we need to consider it as category instead of continuous numbers, right? So we need to do one hot encoding. Okay, so for that my idea is to create a trained pipeline here. Okay, so for that I have to create a pipeline, right? So what we can do is everywhere we have to create the pipeline for all the model. So I'll be going to create the pipeline in the helpers function and call the pipeline here. Okay, that will be helpful. Okay, now next idea is creating a pipeline. First we need to import necessary libraries for that. One is column transformer, the other one is pipeline. See, column transformer sklearn applies transformers to columns of an array or pandas data frame. Okay, powerful tool to apply separate data pre-processing steps to different columns of an array or a pandas data frame. So this actually syncs with our requirement, right? We have numerical column and numerical column as a categorical column. So we have separate data pre-processing steps for each. Okay, so it solves a common issue of managing datasets with mixed data types. See, such as scaling numerical columns while one hot encoding categorical ones. So this is the column transformer from sklearn. Sklearn dot compose column transformers. Okay, so next is our sklearn pipeline. Okay, from sklearn pipeline we can import the pipeline function. Okay, so this allows you to sequentially apply a list of transformers to pre-process the data. So from here we will establish two pre-processing steps. So after that we will be using this pipeline to sequentially apply it. Okay, so let's see how to implement it. Okay, for column transformer is from I think compose from sklearn dot compose import column transformer. Pipeline is from sklearn dot pipeline import pipeline. Okay, next, what are our pre-processing requirements? From sklearn dot pre-processing import standard scalar for our numerical columns and one hot encoder for our category column. We can use get the miss, but since we are applying column transformer under pipeline, it is neat and it will be visibly good and effective in a way if we use one hot encoder instead of get the miss. They both will work out same, but this will make the coding easier and simpler. Okay, so we have used all our pre-processing steps here: column transfer, pipeline, and standard scalar one hot encoder. Now we will have a function. Okay, so we will have a function to create the linear pipeline, right? This is a linear pipeline. I'll make extra spaces. Okay, now def get linear pipeline. So for this pipeline we need two things. One is our xtrain and the other is our model object. Okay, we need to send the model object. We are creating it as a common. So once we get the training and the model object, because we set, see, we are fitting xtrain and ytrain, right? So with the model object, so creating, we are not just fitting now, we are just creating the pipeline. For the pipeline we need xtrain and this model. So xtrain and model object will define the function, our categorical column and our numerical column. We need to define both. Okay, once it is defined, okay, our preprocessor, okay, this is our preprocessor. Okay, I mean column transformer. Okay, I'll call the transformers first. The transformers are we are sending both the standard scalar and the one hot encoder. Okay, then it will be I will use num for this. Okay, I'll send the standard scalar here. So you may ask, we can use the scalar.pickle directly here, but there is no need of that because we are creating entirely a new pipeline. So that pickle file we can take it as a sample or an example to know how to save a model or the object. So here we are defining a new pipeline, so I am taking the standard scalar right away. Then for this I'll be using my numerical columns, right? Then for categorical I'll call one hot encoder. So to handle unknown I'll just ignore so that it doesn't have the pressure. For this I'll give the categorical columns. Okay, this is done. Okay, our pipeline is done. Sorry, preprocessor, the transformer is done. Then here comes our pipeline. The pipeline will be, I'll call the pipeline, first will be my preprocessor. Okay, for that I will send this preprocessor. Once the preprocessing is done, I will call the will call the model. Okay, for this I will use this model object. Okay, this will be our pipeline. Okay, we have defined the column transformer with two activities. One is standard scaler, another one is one hot encoder. Then creating the pipeline for the pre-processing. Once pre-processing is done, the model object will be called. Okay, so defining the categorical columns, that is just weather, right? Next will be our numerical columns. Here first I need to select all the number columns. Okay, then if that column is not in, okay, for every column in this selection, if that column is not in categorical columns, okay, then give me that column name. This will return the list. Okay, first I will be selecting the numerical columns. Then for every column in this selection, if that column is not in categorical columns, return that column in a list. So we will see. Okay. Now to understand pipeline better, I'll print the pipeline as raw and return the pipeline here. Okay. Okay, now we have to use this get linear pipeline in our linear regression model. Okay, instead of doing it in a standard way, we are going in a pipelined way. Okay. This will be our linear regression. Okay, now my linear pipeline will be, this pipeline may be used for other models which requires both standard scalar and one hot encoding. Now our linear pipeline will be utils.get linear pipeline. To that I will send this xtrain comma our model object which is linear regression. Okay, so this will be our pipeline. Next, one thing to understand is we need to ravel the ytrain and ytest through np.ravel. So what we will be having is a series, right? This will be a series, but this will convert it into numpy array. That is, it will be like 1, 2, 3. But once you do the np.ravel, it will be like 1, 2, 3. Okay, this is so much better to work with. So we need to ravel it. Okay, to create a numpy array that is flattening our y, both ytrain and ytest. For this I will use np.ravel of ytrain and saving it again. Okay, np.ravel of ytest. Okay, if we want to see the difference, we can just print ytrain.shape comma ytest.shape. Then again we can print the same now after raveling. Okay, this will be before, let's make it after flattening y. Okay, now okay, we have called the dayload data. We have our data now. Then model object and our pipeline is ready. and we have also set our white train and white test. Okay, now we have to fit the model, fit the data to this linear pipeline, which is linear pipeline dot fit of x train comma y train. Okay, this is where our data is fitted to the model. Okay, next we'll see how this works. Now I will restart the kernel. I've restarted the kernel now. Now we will get the data. Join. Okay. Sorry. Typo mistake. Now it is good. We have got 3336 x train and 834 in our x test. Okay. So first model object, and we are getting our linear pipeline here. See, pipeline steps. First is our preprocessor step, right? Here in our preprocessor, first step is our standard scaler with the numerical columns, comma separated with the one-hot encoder categorical columns, right? So then the column transformer. In the transformers, first we will get num standard scaler, and these are our numerical columns. Then here comes our weather one-hot encoder categorical column. Finally, then our model and linear regression. So this is our preprocessor. Then this is our model. For preprocessor, we have standard scaler and one-hot encoder, and for model, linear regression. Right? Our linear pipeline is ready. Now we have to fit it. Before fitting it, our shape is 3336, 1, 834, 1. Now np.travel. Now after flattening, we will get 3336, 834 as a numpy array. Now with this x train and y train, we are fitting the data. See, this will be our we can expand it and we can see it. Okay, so these will be sent to our standard scaler and these will be to our one-hot encoder. Both will be sent to linear regression. We are not leaving out any columns here. We are making use of everything. Okay, we have created the model. Okay, as per our flow, we have to save the model, right? We have loaded the data and created the model. Now we have to save the model for future purpose. Our pipeline is ready and we have fitted the data and the model is good to go. So I'll create a function called save model first. Okay, instead of, we'll be anyhow using for everything. So we'll use save model. Save model. For that we need the model object, comma, and the model name. Right? So while calling, we need a name to call because we will be saving all kind of 5 different kinds of models. So whenever we need to call a model, saved model, we need a name to refer to it. So while saving itself, we will save the model with its name. So my save model to the path, which is os.path.join. We have this models plots. So this is our models directory. With the model directory, I will save it with the name. Okay. That will be name.pkl. Okay, I'll close it. Now the path is ready. Using joblib.dump, we will save the model. Okay, in the save model path. Okay, finally, once it is done, print model saved successfully in, we'll give the path, no issues in that. Save model path, we'll see in which path it gets saved. Okay, so close the bracket and close the function. This will be our save model. Now utils dot save model of, we should send only the pipeline expects unfitted data, but while saving our model we need to send the fitted model. Okay, so for that we have two. One is here linear regression, that is a model object, and the other one is the linear pipeline with fitted values. We need this for prediction, so we are going to save this pipeline only. Okay, so this pipeline, and we need to give a name for this. That will be direct name, linear regression. It will be easier. Okay, now it is saved successfully in the, we'll go and see inside our models scalar. Now we got linear regression.pkl file. So this is one of the, this is the way I have created. What we have done is, we have done quite a good thing. First we have initialized a database to store the raw data, and what we did was, we established a connection and stored the daily weather df successfully. Then we have started linear regression, so got the parent directory, and using the functions load data, we got xtrain, ytrain, xtest and ytest. Then creating the model object and creating a pipeline. For that, in the helper function we have defined a function get linear pipeline. So in this we have both categorical and numerical columns. For that we are using transformer. Okay, so this will create the structure standard scalar and one hot encoder, and the pipeline will execute it in sequential order, so that we will be sending the preprocessor and the model object. So this will define our pipeline. Once the pipeline is done, we will use that pipeline to fit our xtrain and ytrain. Before fitting, we need to flatten the ytrain to make it as an numpy array. So once it is done, we will be saving the model. So far we have done load data, save the model. Okay, so the another one pending is evaluation and prediction. So for this evaluation we need metrics, visualization, then prediction is inference, that is our forecasting. Okay, so this we will see in our next. So this is how it is going to be. We will be using the load data for all the models, save the model for all the models, and evaluation, visualization and inference is pending. So we will see it in the next session. Thank you.